I'm joined today by Norman Saint, who's going to take you through this presentation. And this, as Norman will introduce it, is looking at historic structures and sort of commercial buildings, touching on a few commercial buildings, but largely historic structures today. What you'll see on the bottom right of your screen is a chat box. If you've got any questions as we go through, by all means, put them in there. We'll probably come to all the questions after the presentation that Norman will give. We'll turn our screens off whilst Norman's giving the presentation, just to save bandwidth and so on. And I'll just be in the background adding a couple of videos here and there. So I think that's all I need to say for now, Norman. So I'll hand over to Norman Saint.
Thanks, Alistair. Hi, everyone. And as Alistair says, welcome to our latest webinar. On this particular session, we'll discuss, as mentioned, exciting ways of non-intrusive and non-destructive methods of ground improvement works that we've completed on some historic properties. Alistair, the slide's not changing. Is that something? There we go. Yeah.
Left and right cursors, Norman.
Yeah, I don't know. Okay, right, we're working. Sorry about that, everybody. So what we're going to do today, we're going to talk about some historic properties that we've worked on, and let's say exciting, non-destructive and non-intrusive methods. And we'll have a brief discussion about Geobear as well. The agenda today, COVID-19. I'm fed up with that blooming COVID-19. It's still with us. I don't think it's going to go away in a rush, but we do seem to be getting on top of it, and we'll have a brief discussion on how we manage working through that. We'll get a brief induction on Geobear and works that we completed. I think there's 4 projects. And then at the end of it, over to you for questions. Right, a little bit about our history. Formerly known as Eurotech, we changed our name in Christmas 2017 to Geobear. We are the global leaders in non-destructive ground improvement engineering, and we have developed a wide range of geopolymers that are now used worldwide. These geopolymers are only available through Geobear, and they've been honed in over many years. Each has its own specialist use, such as clay shrinkage for made ground, water sealing, void filling, and ground improvement in wet or dry areas. In short, the geopolymers we use are specifically designed for their intended use. We have offices across Europe, Asia, and in Ireland, and we've successfully treated over 20,000 properties in the UK and over 200,000 properties worldwide. Our projects come usually with a 10-year warranty for residential properties, and the residential properties also come with an insurance-backed warranty, which is extremely useful. The most important one, we have a significantly small carbon footprint, which is evident across all industries at the moment. We've got green energy protests all over the place at the moment, but happy to say Geobear have a really tiny carbon footprint. We'll discuss 4 projects today. We've got Seaton Delaval Hall in Northumberland. We're very proud of that project. We got nominated for the GE Awards for that programme. We'll talk about St Mary's Church in Doverdale. We've got the old infirmary in Stonyhurst College in Lancashire, and a void filling project on York City walls. A little bit about our materials. The geopolymers we use are targeted between the base of the foundation or the slab or the column pad down to the firm ground. The information is gathered usually for the treatment depths from an intrusive site investigation or a borehole log. And our process works by mixing the geopolymers at the point of injection. And at this point, they start creaming or changing state. Whilst they're still in this liquid phase, and before it begins to expand or change state, it permeates and penetrates the surrounding soils and the voids, and immediately targeting the weak ground. The geopolymers are precisely controlled and held within 750 mil of each injection point. So if we can look at that picture there, we can see a foundation pad or column base. It could be anything really. We can see there the illustration shows how the expansive nature of the geopolymers are kept directly beneath the treated area. So we're not treating ground away from the affected areas. It's at this point, while it's expanding and being held captive to the surrounding soils, that the geopolymers become more dense. Once the structure above becomes easier to move than surrounding ground, an upward movement occurs to the structure or whatever is beneath or above us. It could be a slab or an airport runway, a castle wall, etc. The process is not affected by adverse temperatures. We've actually completed works in temperatures as low as -15 in the Nordics and as high as 54 degrees centigrade in Abu Dhabi. The resins are approximately 10% the weight of concrete, and they are fully cured within 15 to 90 seconds dependent on the chosen resin. And we have up to 30 resins available. All our resins are completely closed cell and thus totally impervious to water. And I think Alice has got a little video if we play it now, and you can see the geopolymers expanding. There's the geopolymer, and it's what we call the liquid state, and there it starts creaming. And then we get that expansion. It's that expansion that you can see there that runs into the voids on the loose ground. Obviously, that was free rise. In its captive state, it becomes more dense. So it's only a short video, but it shows how the geopolymers work. I touched on there where we get the treatment depths from a site investigation. Here is a typical site investigation. We used this on a project for a silo at a major food manufacturing company. As you can see, it details the soil depth and the soil types, and we've got dynamic probe test results. On this particular project for the silo, we were given a specific target strength of 20 kilonewtons per meter squared to achieve by the client. The target depths we identified at 3.5 meters below the foundation. And on this project, we would verify that the ground improvements has been achieved by a heavy dynamic penetrometer test, or we could do various other tests, core samples, etc., depending on what the clients have specified. But as you can see, that's typical site investigation. I'm sure you've all seen them before. On the left side, we've got the depths of the treated soils with a description of what the soils are. And on the right, we've got the dynamic probe test results pre-works. The post-works obviously would have been much stronger than that. So that's a typical SI that we'd ask for on most projects, not all projects, but ideally we would like this. And it helps us form our design for the projects that we work on. Here's our first project, which, as we mentioned before, it's Seaton Delaval Hall. This is a grade 1 listed country house on the coastline in Northumberland. It's situated between Seaton Sluice and Seaton Delaval, if you're familiar with that area. And it was designed by Sir John Vanbrugh in 1718 for Admiral George Delaval, hence the name. It's now owned by the National Trust and more recently has been open to the general public. Over many years, beneath the hall, the soils have been compacted beneath the structure, and also leaking drains had softened the soils, washing away some of the fines. A solution was required that would remediate these soils without any excavation or damage to the historic building. And following a number of engineering meetings, which I was involved with, and a detailed proposal was delivered by Geobear for our non-intrusive geopolymer injection was chosen. We were required to improve the strength of the ground beneath the foundations to the west wing of the historic house, where significant cracking and movement, both internally and externally, could be seen. The site investigations revealed various treatment steps ranging from 1.5 to 7 meters below ground level. And our geopolymer material was injected at 1 meter intervals around the affected areas. With the groundworks verified by post-works through heavy penetrometer testing, as we discussed earlier. All the works were successfully completed within 2 weeks, ensuring that there were no delays or alterations required to the client's programme of works. There was an extensive renovation going on at the same time as our works. Another reason the Geobear method was chosen was for future archaeological digs, and these can still take place if required, as our geopolymers can be removed using just normal excavation methods and shovels, etc., which obviously minimises any damage to any archaeology that may be in the ground that we've injected to. If you see the bottom picture there, that was the rear of the building. So if you imagine injection depths, I think at that point we're down to 2 meters in that particular picture. So they'll be spaced every 1 meter along the wall down to the various steps. On the picture above, beneath each one of the columns on the colonnade there, the treatment depth was down to 7 meters. I think, Alistair, we could play a short video now. It shows our works that were completed, and I'll do a little brief over talk while it's on. Thanks, Alistair. Okay, it should start shortly. There we go. And there's the colonnades there, and the treatment beneath those, as I say, was 7 meters. And then we went round to the rear of the building. There we go. You should get the injection points being laid. So there we go. There's each injection point, and they were spaced at 1 meter intervals around the property. Every hole that we do is logged and checked, so you get a full detailed report at the end of every injection. So there we go. There's a 60 millimeter hole injected down through the floor. They would go down, in this case, to 7 meters. As you can see there, how non-intrusive our process is. And there's the 12 millimeter steel injection tubes. And there's an animation now, which is not too dissimilar to the way the process works. There's the geopolymer going in. And you can see how it fills the micro voids and the voids beneath. And if you picture that as expanding, that becomes denser every time. So all around each one of those treatment areas, the resins or the pressures are pushing out in all directions. Eventually on the last one, here we go. We're directly beneath the base. And there we go. We've got a pure column, and that went down to 7 meters below each one of those bases of ground improvement. You see how little we've affected the surrounding soils away from the structure. So you're only paying to treat the areas that have been affected, and you're not disturbing other areas. So that was a great project. We're extremely proud of that one. As I say, that got us nominated for the GE Awards down in London. I think we've got another video now of a project we did at Eton College. My colleague Kevin will talk us through this one if we're played. I'm going to mute myself because I think you might get a bit of background. So this is a really good project. This one, if you could play this one, please, Alistair.
The works we were asked to look at were part of a wider scheme, which involved the demolition replacement of the external structures between Durnford House, which is a boarding house for the students, and the school hall and the college memorial buildings. Primarily, it was to refurbish the inside where they had a lot of asbestos, which they needed to get rid of, but also to install a hydraulically operated floor, which meant the floor could be lowered for various functions, and then reinstated afterwards to give them more floor space. The area of existing basement in front of the stage is being lowered by, I think, 1.2 meters to accommodate the hydraulic floor, sorry, the lift for the floor. There you can see the, prior to demolition, that's the existing school hall floor. And underneath that, there's a series of vaults and a basement. When I say a basement, it's about 1.2 meters high in headroom. So the proposed construction involved reducing the level of the basement. However, where the foundations of the columns came down, there was concern over load transfer into the excavation, i.e. the zone of influence beneath the existing foundation projected into the proposed dig. So we were asked to grout, or the engineer came up with a grouting scheme, and we offer an alternative with geopolymer to inject beneath the existing foundation to remove the load or the potential for load transfer into the excavation. In addition, the water table is very close to the underside of the proposed slab, so they asked us to inject into the area to be excavated to stop the potential of any groundwater ingressing into the excavation. There were 6 columns with associated foundations on the perimeter of the excavation, which we needed to treat to increase the angle of internal friction and to remove the potential for load transfer into the excavation. And then there was an area where they were reducing the level, or where they're going to reduce the level, in the front of the stage, where we injected beneath the existing slab down to a level to permit the excavation and installation of the new floor slab and walls. Okay, so the school hall is located between Durnford House, which is the boarding school, or the boarding rooms, and the library building, which is the building on the right, the cupola, behind which you can see part of the college. Access was very, very restricted, and it was necessary for us to park on the high street. We're approximately 75 meters away from where we were injecting. As you can see, we were able to work around the demolition of the existing basement, installing the tubes for the injection beneath the existing basement slab. This is a photograph of the foundation that was exposed, foundation beneath the column that was exposed after treatment. And you can see there the stone corbel, which we drilled through and treated the ground beneath. The markers on the wall, precise level survey, so when they excavate it, they'll be able to monitor any movement of that column.
It was a really good project, that one that Kevin just talked about there. We've got a number of different methods for our geopolymer. We've got water retention, we've got soil retention, we've got ground improvement. And we've got ongoing works with a live renovation of a good historic structure there. And we'll talk about another couple of projects. This one is a church, so not as thrilling as Kevin's Eton Hall, but still nonetheless it's exciting for the way that we worked on it. The damage to the church was on the west gable and has been caused purely by clay shrinkage. Sorry, that's the wrong script. Sorry. Bear with me 1 second. Oh, my notes for that one are gone missing, so I'm going to have to do this from memory. This is a project that I worked on. The damage to this part of the church was caused by collapsing tombs. And you can see there on the top picture, there's two burial spots there. I'm not sure who they are. Well, unfortunately, beneath the ground, the coffins and the voids and the crypts had started to collapse, and it caused cracking to the wall. So we used our geopolymer. In this case, we started with a void filling geopolymer, moving on to a ground improvement geopolymer above where the ground had been disturbed. And you can see on the top picture there, it's a repair post works following our work. Now, I've shown this one because this church has come back to the fore again with further works. But the picture on the bottom right, we did this original works in 2012. And this picture on the bottom there was taken last year by myself. And you can see the repair is still extremely tight. There's been no further movement. It's as good as the day that we completed the works, which, hey-ho, is 9 years ago now. So we've had a lot of dry spells. We've had a lot of rain. We've even had some cold weather as well. So it's a great example of how Geobear is a permanent repair, not a temporary repair. So please don't anyone treat this as a temporary project, or our projects are permanent, guaranteed, and repairable afterwards. Now, hence, if I come forward now to our latest project, here the damage is slightly different. We're at the other end of the church. The green area on the treatment plan there is the area that we first treated. The damage to the brown area is on the west gable, and this has been caused purely by clay shrinkage. There is a large yew tree. You can just see on the top picture there, the leaves of it. They're within, I think, 3.5 meters of the church. Now, the girth of the tree, it's at least a circumference probably of 5 meters. It's a large tree. And then we completed this repair using the same method or the same geopolymers as the east gable, where we done the void filling. The whole process would totally fail. As I mentioned earlier, we've got specific resins for individual problems. And this time we'll use our geopolymer specifically designed for clay shrinkage. On the original treatment plan, the green area, our injections, as with Seaton Delaval Hall, were on a 1 or a 1.2 meter spacing linearly across the treatment area. For clay shrinkage, we reduced these injection spacings. And on this one, our design is going to be on 500 millimeter injections. The yew tree will remain in situ post-works. I mean, that's an extremely old tree. It's at least a couple of 100 years old. We're not allowed to remove that tree or affect it, and our resins will not affect the roots or the life of that tree. And this project illustrates that one geopolymer does not fix all faults. There is no silver bullet with geopolymers, and that's why we have ranged over 30 to choose from, each with its own particular use. And Geobear have a specialist team of specialist engineers who oversee every single project, which is another asset to our armory, if you like. Each project team will get to know their customer intimately, so you never have any problem ringing a large company up. No one knows who's dealing with what in each company. Every project has its own specific engineer its own area managers such as myself, and we'll know who the technicians are who have worked on that. So it's a very close-knit process, our works, and we like to keep everything moving as smoothly as we can. And again, all our works on this were completed on time, on budget, and within the specified period quoted. Here's another project. It's Stonyhurst College in Lancashire. Stonyhurst College is a co-educational Roman Catholic independent school. It's also, as our other projects, a Grade 1 listed building, and it has suffered from historic movement. The site investigation in this instance showed poor soils down to 4 metres below the ground level. Our treatment depths were targeted to 3.7 metres below the foundation base. This fabulous building was returned to full use following refurbishment, and our non-destructive process was chosen as against traditional piling, as this would have disturbed the building even more. So if you imagine a strong, traditionally piled repair against that building, on the strength of the grounds that the site investigation showed would have made more further damage movement to that structure. Our standard geopolymer for ground improvement was used on this project. Now, if you see the treatment plan, you can see how we can target specific areas. In this instance, they were all internal treatments. So it shows how portable and easy to move around our equipment is. Kevin touched on the previous visit there. Our trucks have an extendable hose of at least 100 meters. So we don't have to be in and on top of the area. We can park our vehicle, which is a fully self-contained vehicle. Each vehicle has its own pump, its own electrical generator, its own air compressor. And this is where all our resins are. So they are fully self-contained specialist injection units. I'll say you can see from the treatment plan there how we've spread our areas around 4 separate areas. And each one of those had a different treatment depth. I think they range from memory from 3.7, as I touched on before, down to 2.5 meters on the internal wall at the center there by the large chimney breast. So it shows how Geobear, we don't have to treat grounds that are not needed for treatment. We can specifically target very tight and controlled areas. All our injections are monitored. The second we get an influence on any structure that we're moving, the instant we stop injecting is the instant that we stop any movement to that structure. So it's extremely precise, extremely tight, and it's highly controlled. Our next project is Dumbarton Castle up in Scotland. Apparently it was a French prison. I'm not quite sure why there's a French prison up in Scotland, but that's another story. At Dumbarton Castle, and the project shows how versatile and adaptable Geobear can be to reach difficult to reach projects. The structure is situated at the top of Dumbarton Rock with no vehicle access whatsoever. The structure at the top had settled 15 millimeters and was 145 millimeters from vertical. The building was constructed on top of a stone foundation, 1.2 meters below ground level. Water draining off the rock face over the rear of the building had caused differential settlement. Geobear's objective was to stabilise the wall without disturbing the building. All the work was completed successfully again and without any disruption to the tourist attraction. Now, access, as I say, for this site was extremely difficult. The only route to the site was by climbing 218 steps. And believe me, I felt every single one of those steps climbing up. It's 55 meters high from ground level. Now, touched on before, each injection specialist unit has a 100-meter hose. In this instance, the nearest we could park our injection unit was 210 meters away. And our specialist teams involved at Geobear adapted our equipment so we could reach the area to be treated. Now, as I say, it's 55 metres high up the ground. The original ideas, we were brainstorming at the time. We thought of all ideas, bringing the army in, using aircraft, helicopters to lift our equipment up. But in the end, we designed our own specific adaptation to this. We enabled the injection hose to be extended to over 250 metres. And we employed a team of specialist steeplejacks who literally climbed up the face of the sheer rock of Dumbarton Castle to get the injection hose up. This enabled our injection teams to work. So if you can picture this self-contained injection unit, it's not only pumping the geopolymers 210 metres, it's pumping it also 55 metres vertically up a sheer rock wall to get to the treatment area. All the work again was completed on time, on budget, and it was still open to the local tourists as well while our work was going on. So there was no revenue loss at all. So we're extremely proud of this one. Access, trust me, was extremely difficult. Traditional piling would have been impossible. Traditional underpinning, I'm not sure how you'd have done it, how you'd have got a cement mixer up there, to be quite honest. I don't know how you'd have done it. So it was a great project for us. Now, another one, this is slightly different. This is void filling. It's on York City walls. It's one of my favourite cities, York. I love it. The walls remain the most complete example of a medieval city wall still standing in England today. And they date back as far as the Roman period. With such historic pedigree, both construction and age-related wear and tear was inevitable, and some significant voiding discovered beneath one of the sets of steps leading up to the rampart of the Monk Bar Gatehouse. The voiding beneath the steps had begun to impact on the stability, causing the steps to loosen, with the potential for them to collapse. Not only would this have been dangerous for the health and safety of perspective, but it also impacted on the historic appearance of this much visited tourist attraction. York City Council, who managed the walls, required a permanent solution that would effectively fill the void beneath the steps, both stabilising and supporting them. Yet any such solution had to have its methodology and materials passed by historic buildings. This was a long-winded project, as you can imagine, I'm sure you're aware, but we managed to get approval from historic buildings. They would have no deterrent effect on the steps of the wall, so that basically our geopolymers would not affect any of the surface of the wall that were there. As well as being a highly trafficked area, any solution would have to be quick and efficient and be minimally disruptive. So there on the top picture, you can see one of our smaller vehicles, and to the side and the base, you can see the steps below. Where the guys are standing at the bottom is where the severe voiding had occurred, and those steps were rocking. And I believe they were closed down to the public. One day later, following our treatments, the steps were opened up as a finished project. So again, it emphasises how non-disruptive, how fast we can work, how least disruptive we are to the traffic, and non-intrusive methods. And again, please bear in mind, this is a permanent fix, not a temporary fix. And that's the end of our presentation. What questions do you have? As Alistair mentioned, you can email. I'll come back to video now.
Yeah, thanks, Norman. That was an excellent insight to how we deal with historic structures. There was a chat box at the bottom of the screen. I think I can see some questions have come in already, so we may as well dip straight into those, Norman. So Ian asked at the top of the chat there, what centres for investigation boreholes would you require for a strip foundation?
A strip foundation depends how long that treated area is, Steve. So say, for instance, we're talking of a 10 linear meter treatment, usually on an area like that, one site investigation or borehole would be sufficient. If we're going around the corners, for instance, and both corners are moving, we would like an investigation under each corner. So it's each individual one. It depends on the severity of the damage, really, to be honest. But usually on a job 10 to 20 linear meters, 1 to 2 boreholes will be more than enough.
Okay, thanks. Hopefully that answered that for you, Ian. Steve asks of East Riding Yorkshire Council, were you asked to apply for listed building consent for your works? I don't know if that's applicable to a specific project, but generally, do we get asked for listed building consent for our works?
It's not something we normally seek after. A lot of the work that we have done has been with Historic England or the National Trust, and they have sought the world. We've had to gain approval, as on York City Walls, from the council in York. To gain their approval, we had to prove how our resins were acceptable, were up to the task of holding the wall and filling the void, and without disturbing the appearance of the walls or the rocks or the steps. So every case, I suppose we do have to gain approval on every case.
Yeah, and in instances, Environment Agency would have to approve some works, but our materials are inert and don't affect the groundwaters of the environment, do they, Norman?
No, they're completely environmentally friendly. All our waste material that we get, we remove ourselves, and it just goes to normal landfill. So there's nothing hazardous about the materials. Yeah.
And I know Greta Thunberg in the week was talking about zero carbon, blah, blah, blah. Yep. But we genuinely are sort of zero carbon. So we're not the blah, blah, blah bit of that.
It's a great thing, that, Alistair, because the carbon footprint now is a massive thing across all of our industry that we work. We don't only work with historic properties, we work on new properties and across every spectrum, and the carbon footprint on every single job now is massively important, to the fact that we've got a dedicated team at the moment doing a specialist project on our carbon footprint. So that should be widely available very quickly.
Yep. Ian's second question, actually, could we give an indication of cost? That's a difficult question to answer.
It is a difficult question, Ian. Cost-wise, we're on par with any other traditional method of piling or underpinning. Specific costs vary from the depth of treatment that we're treating, the type of geopolymer that we're using, the spacing that we touched on 2 projects earlier where we were 500 millimeter spacing, 1 meter spacing, and 1.2 meter spacing. But the crutch of it is we are on a par with any other method. The big plus is we're massively quicker, massively less disruptive. So as a rule of thumb, a week of traditional underpinning is generally 1 day's work to Geobear. So they're the pluses. And another one that's worth mentioning as well is Kevin on Eton College. He touched on it. There was a lot of asbestos in that building. And because we are only removing the drill spoil from a 16 millimeter hole, any toxic or hazardous ground that's removed is easily and safely removed. We've only got the drill spoil basically to worry about. So you've lost that massive cost of clearing up contaminated ground and contaminated areas. So it's another plus for us.
Thanks, Norman. So James asks, roughly how long does the investigation phase take and development of proposed polymer choice? So what sort of timescales are we talking?
Oh, it's very fast. It depends how fast we can get the SI team in there. We've turned rounds, we've done emergency works. One project I was involved with, it's not historic, but it was a mains water burst beneath an internal factory slab, and it was in Wrexham, North Wales. And it happened on Friday. At that particular point, I was driving up to Cumbria, and I was by the Lancaster services when a very frustrated guy from the factory in North Wales rung up. He was in dire straits. Whole production facility had stopped. So that was about 3 o'clock Friday afternoon. At 9 o'clock the next Saturday morning, so the very next day, we had a team on site working and injecting. And over that weekend, we stabilised that factory. So we'd gone from possible total closure to losing a Saturday morning's work. So we can turn things around rapidly. So very, very fast, to be quite honest.
Yeah, that's a good example, Norman. Thanks. Evan asks, do you do domestic projects for houses? So do we do residential projects, and how much? Well, you've touched on the costs, Norman, but essentially the core of the business stemmed from residential works, didn't it?
Absolutely. And we think we're doing 40 plus properties residential a week at the moment. So yes, we do an awful lot of residential properties.
Yeah.
Before, they come with an insurance-backed warranty as well.
Yeah, and Vincent asks, how many years of warranty do you give for this sort of remediation?
Right, it's usually 10 years. That 10-year comes from a standard NHBC type new project. We'll give you a 10-year warranty on a 700-year-old cottage. The NHBC will only give you a 10-year warranty on a brand new house. So we'll exclude it. That's why it's 10 years.
Yeah.
It's as simple as that.
Yeah, and Chloe, is the resulting strengthening polymer mildly flexible to accommodate natural movement and surrounding ground conditions, as opposed to solid and strong concrete methods that can cause cracking elsewhere?
Cool. No, it's exactly the same. As we touched on before, we're massively lighter than traditional concrete, but we are just as dense. You know, it is as strong as poured concrete.
Yeah.
So we're not going to cause any further movement. What we inject under is a permanent repair. There may have to be crack repairs such as helical bar or similar following our works to repair the crack. We don't repair the crack, we only do the ground improvement works. So as long as the crack repairs are done and adequate, it's a finished project. Yeah,
there's no sort of plasticity built into our polymers for any reason that we currently use it for. However, our R&D department, I'm sure, have probably looked at options like that. I don't know any good examples. James says, good question. Yeah, good question. Challenging question. Anybody else have sound issues? Sorry, Jamie, that's a bit too late for that question there. I didn't realise you had issues. We are recording this, so I will send out a recording of this in case you want to share it with anyone else later on today anyway, so hopefully you can watch that, Jamie. Dennis, how would you comment on the effect of polymer on historical tombs? Are these injections acceptable for use in historic cemeteries, Norman?
Absolutely, yeah, absolutely they are.
Yeah.
We've done it. The Doverdale Church is a classic example. We filled those tombs that had collapsed.
Yeah.
I don't think the people were too objective who were in there, but
no, exactly. It's obviously it's challenging when there's tombs involved, but obviously we liaise with all parties involved and do what's absolutely necessary and what we're allowed to do. So.
We have an active inquiry. I can't tell you which church it is because it's still only an inquiry in Manchester. We're specifically going to fill the tombs below the vestry on the inside of a church. So yeah, we haven't got the job yet, but we are pricing for it. So yes, we can fill tombs. Yeah, absolutely.
Yeah. Did we fill the tomb at Bath Abbey for a particular project, or is it beneath the tomb? I don't know if you know that one. It was one of Jeff's, but
we did do that. I'm not familiar with the actual total project, but yes, we did.
Bath Abbey. So this is something we use on all over the sort of historic structures. Dennis, I hope that answers it. If you've got a specific question about any project you're working on, please get in touch afterwards. We'll speak to you directly on those. So Stephen asks, you mentioned being able to stop movement quickly. How does this expansion time from injection to curing affect this on domestic subsidence case? Secondly, where do you have an old step? Secondly, where you have an old stepped brick stone foundation, is this more difficult to treat than concrete foundation?
No. We treat cobble foundations regularly. I've just priced a project with a cobble foundation in Scotland. It's a tenement. It's not a historic structure, but it's a typical Glasgow tenement block. It's got cobble foundations. We'll inject beneath them. We alter the spacing, obviously, because you've not got the concrete plinth, if you like. So it's a cobble brick, so we tighten our centres up. So absolutely, yeah, it doesn't affect the treatment method at all, really. That's fine.
Yeah, and is there a minimum or maximum depth for correction works by Geobear?
Right. We generally do shallow depths, but we have treated down as far as 25, 27 metres. It's very rare, but I think of a vast majority of our work is 10 metres and less. But yeah, we can treat down 15. Once we go down to greater depths, then we probably become more expensive, and probably traditional piling would then take over. You start getting your big rigs in there.
Yeah. And James just is clarifying, Chloe's earlier question was related to the differential movement as a result of over-stabilisation from a localised concrete underpinning. I'm not aware that we have that issue at all, Norman, are you?
No, not at all. Not at all.
No. So our designs are engineered, but we've got and signed off by a chartered engineer, so they would take into account anything like that, Chloe or James. So hopefully that answers that. But if you want more details, please get in touch and we can clarify. But it looks like we've gone through all the questions, Norman. So I think that's it. I'll just say thanks to everyone for joining then, and I'll drop an email to you later on today. If you need a CPD certificate, just let me know, because we do this is an accredited session, so by all means do that. Thanks again, Norman. If you've got any questions on particular projects or anything you were thinking about, by all means contact Norman directly. I'll copy Norman in the email later on. So that's it from us. We do have further sessions coming up. So if you look on our website, we cover loads of different sectors. So there's some on railway, there's specifically residential solutions further down the line as well. So join those on our website, and I'll see you next time. Thank you. Thanks, guys, who's saying thanks. Okay, cheers, Norman.
Thank you, everybody.
Okay,
Bye. Bye.